An integrated view of Greenland ice sheet mass changes based on models and satellite observations. In this presentation, our goal is to offer you a quick summary of the research and conclusions. Please follow the links to review the research in further details. Thanks to all the authors and publishers for making this research public, thereby advancing science and innovation. The Greenland ice sheet is a major contributor to sea level rise, adding on average 0.47, give or take 0.23 millimeters a year to the global mean sea level between 1991 and 2015. The cryosphere as a whole has contributed around 45% of observed global sea level rise since 1993. Understanding the present-day state of the Greenland ice sheet is therefore vital for understanding the process controlling the modern-day rates of sea level changing and for making projections of sea level rise into the future. Provide an overview of the current state of mass budget of Greenland based on a diverse range of remote sensing observations to produce the essential climate variables, or ECVs, of ice velocity, surface elevation change, ground line location, calving front location, and gravimetric mass balance, as well as numeric modeling that together build a consistent picture of shrinking ice sheets. Also combine these observations with output from a regional climate model and from the ice sheet model to gain insights into existing biases in ice sheet dynamics and surface mass balance processes. Observations show surface lowering across virtually all regions of the ice sheet and same location up to 2.65 meters a year between 1995 and 2017 based on radar altimetry analysis. In addition, calving fronts at 28 study sites representing a sample of typical glaciers have retreated all around Greenland since the 1990s, and in only 2 out of 28 studies locations have remained stable. During the same period, 2 of 5 floating ice shelves have collapsed while the locations of the grounding lines at the remaining 3 float ice shelves have remained stable over the observation period. In a detailed case study with the fracture model at Petermann Glacier, we demonstrate the potential sensitivity of these floating ice shelves with future warming. GRACE gravimetrical derived mass balance, or GMB, data shows that overall Greenland has lost 255, give or take 15 GT year of ice over the period of 2003 to 2016. Consistent with that shown by IMBIE and the marked increase compared to a rate of a loss of 83, give or take 63, GT year in the 1993 to 2003 period. Regional climate model and ice sheet model simulations show that the surface mass processes dominate the Greenland ice sheet mass budget over the most of the interior. However, in areas of high ice velocity, there is a significant contribution to mass loss by ice dynamical processes. Marked differences between the models and observations indicate that not all processes are captured accurately within models, indicating areas of future research.